section chapter 8, section 4, trigonometric substitutions. I want you to look at these triangles. These triangles are right triangles, and we have an angle theta in each, but the way we put the A's and X's are different. Look at the red sides here, edges, right? A and X is in here, and hypotenuse is just a square of the squares of sum of the squares. And if A is here and X is here, and we have square root of A squared minus X squared. If X is here, A is here, square root of X squared minus A squared. So we have three different situations that we can put. Why did we do that? There's a purpose for it. First of all, in the first one, we want tangent theta to be X over A. So in other words, X is A times tangent theta. In the second, we wanted sine theta to be X over A, or X is A times sine theta, okay? In here, we wanted secant theta to be X over A. So in each time, so this is for tangent theta is X over A, sine theta is X over A, secant theta is X over A, okay? We did this on purpose because when you do that, this expression, which is square root of A squared plus X squared, happens to be this much simple, because if you put X to be A times tangent here, you square it, A's are gonna, we have A squared plus A squared tangent squared. Take out the A squared, you have 1 plus tangent squared, but 1 plus tangent squared is secant squared. Absolute value of secant squared is absolute value of secant theta, and A is out like that. We did this on purpose. Like in here, if you choose X to be A sine theta, then square root of A squared minus X squared is A squared minus A squared sine theta. Take out A's, A squared, and then 1 minus sine squared. 1 minus sine squared is cosine squared. Square root of cosine squared is absolute value cosine. And here, if X is A secant theta, put it in A squared secant squared theta. Take out A squareds out as A. We have secant squared minus 1, which is theta, tangent squared theta. Absolute value is, square root is gonna give you absolute value of tangent theta. So everything is gonna give us this simplified expression. That's why we prefer to have these substitutions like that. So we have such a substitution, 3 different substitutions. Now, look at that, the arctangent, arcsine, and arcsecant, they are written as a function of X over A. Look, theta is arctangent X over A, theta is arcsine X over A, theta is cosecant, arcsecant X over A. So all of them are a function of X over A. So how would you do the trigonometric substitution? First of all, you're going to write down the substitution, one of the 3 actually. You're going to calculate the dx, and then we are going to specify the selected values of theta for the substitution. We are going to substitute the trigonometric expression and calculate the differential into the integrand, and we are going to simplify the results if we can. And then since the integrand is simplified, now we are going to integrate the trigonometric integral. And then of course be careful about the domains, restrictions about the theta values. Look, theta takes values between negative pi over 2 to pi over 2, not everywhere, okay? Here theta is again negative pi over 2 to pi over 2, and here theta takes values between, I think, 0 and pi. Okay, be careful about that. And then we reverse the substitution at the end after we find the integral's result. but we have to draw a reference angle for that and convert everything back into x, because the result could be in theta, but we have to convert it back into x. For example, let's say we have the substitution x is equal to tangent theta. The reference triangle for it is going to be this triangle. Tangent theta is x over 2. So this is our reference angle, reference triangle. Okay, because afterwards we would need secant theta, so we have to find the secant theta by looking at this reference triangle. Secant theta is, what's secant theta? 1 over cosine. What is cosine? Cosine is 2 over this. Reciprocal of this is square root of 4 plus x squared over 2. Hyperbolic sign, just forget that. In example 3, you would do the substitution. X is equal to 3 sine theta. But what is the reference angle for that? Sine theta is x over 3. Sine theta, here's theta, sine theta, x over 3. Then this has to be square root of 9 minus x squared. So your reference triangle is important. Once sine theta is x over 3, in the example we would also need cosine theta, depending on the question, of course. Cosine theta is easy to find. You can get it from the reference angle. Cosine theta is 3 over, cosine theta is this over 3. Okay. This is example 4. The substitution used in example 4, x is equal to 2 over 5 secant theta. Okay. Okay, so in other words, secant theta is x over 5 over 2. What is secant theta? 1 over cosine. Then cosine theta is 2 over 5x. So we use this to find the solution. I will solve some examples about that. Okay, these are again from fall 2019 lecture notes. Okay, here actually what we had talked about, it is convert the following given expressions into trigonometric expressions by using substitution. It says square root of a squared minus x squared is, we let x is equal to a sine theta, and we get it to be a cosine theta. Actually, we should have absolute value here because we don't know whether this is positive or negative. Okay, similarly, let's try to find this. We do the substitution x equal to a tangent theta, and we are going to get a times absolute value secant theta, it should be. And this, for this one, we would use x equal to a secant theta, and we get, if you put it in, you get a times absolute value tangent theta. Okay. Let's evaluate. Let's do these examples. Let's look at this. The question is which there are 3 substitutions, trigonometric substitutions. Which one I'm going to use? Which one does it look like? A squared minus x squared or x squared minus a. This is x squared minus a squared, so we use secant theta for it. But I'm looking for a squared minus x squared, which is the first one. The first one tells me that I should use x is equal to a sine theta. So I'm going to go back and I'm going to use x is equal to 3 times sine theta here. Okay? For this one, it is x squared plus 4. This is like x squared plus a squared. For x squared plus a squared, I am supposed to use x is equal to a tangent theta. Okay? So for the second, I'm going to use x is equal to a times tangent theta. This is x squared minus a squared. And for this, I'm going to use x is equal to a secant theta to get to the answer. Okay? Let's do that. For the first one, I'm going to use x is equal to 3 sine theta, and square root of 9 minus x squared is 3 cosine. Okay, and because we just put it in here. Look, a 9 sine squared theta, 9 take 9 out, I have 1 minus sine squared theta, 3 times cosine theta, you get it. Okay, and then x is, since we have this substitution, what is dx? Because I need to find dx. So I found this, I need to find this. This is easy. So dx is 3 cosine theta. Integral I is equal to integral square root of 9 minus x squared over x squared dx. So this is, we simplified it. This was 3 cosine, dx is 3 cosine d theta, and x squared is 3 squared sine squared theta. Now we are going to simplify the 3's here. I have cosine squared on top, I have sine squared in the bottom, and this is going to give me cotangent squared theta, but cotangent squared theta is cosecant squared theta minus 1. Okay, so then cosecant squared theta is antiderivative of negative cotangent, and antiderivative of 1 is theta. So this is my final answer. Okay, this is for I though. Okay, yeah, I is that. This is the reference angle, okay, that we used. Okay, so this is my final answer, I said, but something is wrong. I have to use reference angle to convert theta into x's, x values. Therefore, I drew this reference angle here. Reference angle is going to help me to write back everything in terms of x. So here I have cotangent theta. So I look at here, what's cotangent theta? Cosine over adjacent over opposite, this over this. Okay. Alright, so I got that. Minus, what is my theta? Because I'm interested in theta. Sine theta is x over 3. Then theta is equal to arc sine x over 3. Okay, arc sine x over 3. So instead of theta, I write that and I finish it off. My second example, if as you remember, I would use x is equal to a tan, which is 2 times tan, and x squared plus 4 would be equal to 4 times secant squared theta. Okay, and I put it in and I get square root of x squared plus 4 is equal to 2 secant theta. Now this is okay, I found it. This is also okay because they take the square. And what is dx? If x is 2 tan, then dx is equal to 2 secant squared d theta. So I got that too. I put everything in. Okay, this is dx, this is x squared, this is square root of x squared plus 4, and do the simplifications. Tan is sine squared over cosine squared. I have, this is 1 over cosine, cosines are going to cancel. I have 1 over 4 cosine over sine squared theta left. Okay, then you can say this is du, you can say this is u squared, u is sine, du is cosine d theta. Okay, so this is du, this is u squared, 1 over 4 integral du, u squared is equal to 1 over 4. This is the power rule, and you get this. You want to convert everything into x. U is sine, so negative 1 over 4, 1 over sine. But we have to go to the reference angle. What is our sine theta? Reference angle tells us that sine theta is x over this. Put it back in, and our final answer is going to be that. Okay, this is the final answer, plus c. And example 3, in this case we would know the substitution that we would put x is equal to a secant theta. So what is this first? We need to find it out, and then we have to find dx. If x is equal to a secant theta, dx is a secant theta tangent theta d theta. This is the substitution box. And then we have to find this expression. square root of x squared minus a squared. If you put it in, we knew that it's a tangent theta. Okay, we put everything back in, so a tangent theta in the denominator. For dx we have a secant theta tan theta. Tan thetas cancel, a's cancel, we have only secant theta left. We know that the integral secant theta d theta is natural log of absolute value of secant theta plus tan. We added c because it's indeterminate integral. And this is not the final answer because we have to look at the reference triangle and write everything back in x. What is secant theta? Secant theta is what? 1 over cosine. Okay. What is cosine? Cosine a over x, x over a. Okay. This is x over a. And what is tan? Tangent is this over this. We write back in here. So our answer is integral I is equal to natural log of this expression plus a big C, and we are done.